Hi guys, this is day 5 of the 42-day revision challenge, and we are going to do price elasticity of demand, or PED, which is probably a very important topic when it comes to exam questions, both essays and MCQs. So let's start with that. We define PED as responsiveness of quantity demanded to a change in price. In other words, it tells us that how much your quantity demanded will change when there's a change in price. So if I look at my demand curve is downward sloping, right? Let's say we call this a normal demand curve, which is a downward sloping demand curve. We know when the price of a good goes down from, let's say, P0 to P1, the quantity demanded will go up. So this calculation of elasticity of demand sort of working will tell us by how much will quantity demanded go down. Let's say a producer lowers the price by 10%. So we want to know how much is the quantity demanded is going to change by, and we use a formula where PD is equal to percentage change in quantity demanded over percentage change in price. So it tells us that if, for example, PED has a particular value, let's say 0.5 or 0.6, whatever, and if I give you a change in price, let's say 10%, we can find out the change in quantity demanded. Now, one thing to remember here is just that when the price goes down, normally we see the quantity demanded to go up. And that's why PED value is always going to be negative. Why? Because of the inverse relationship between price and quantity. When the price goes down, quantity demanded will go up, and vice versa. This means that there is an inverse relationship between price and quantity, and that's why this inverse relationships lead to what we call a negative PED, and that's why sometimes what we do is that since we know that PED is always negative, we sometimes ignore the minus sign. Let's do an example where we change the price and as a result change the quantity and find PED of a good. So let's say previously your price P0 was 10 and then price went to $20. So price is going up from 10 to 20. And let's say quantity previously was, let's say, 100, and because of the change in your price is going up, let's say the quantity goes to, for example, 80. So price is going down, the quantity is going up, and let's find out PED using our formula. So our formula for PED is percentage change in QD over percentage change in price. So what is the percentage change in QD in this case? Well, 80 is the new quantity minus old quantity is 100 over old quantity 100. Remember, percentage change is new minus old over old times 100. So 80 is new minus old is 100. 80 minus 100 over 100 times 100 over price would be new minus old, which means 20 minus 10 over old, which is 10 times 100. So I will get myself in the numerator, I have 80 minus 100, which is minus 20, and I can cancel this. So that's minus 20 over, and in this case 20 minus 10 is 10 over 10, which would mean 100. So I'm looking at minus 20 over 100, or in this case I can cancel this as well. So that will be 2 over 10 or 1 over 5, which is equal to minus 0.2. Now minus means, of course, there is an inverse relationship between price and quantity demanded, but 0.2 means that this relationship seems to be what we call inelastic, and I'm going to talk about this in a little while. But the way we find the value, an important thing to remember is this, that the way we find the value is we always look at new minus old over old times 100. So that's the way we calculate PED. Let's now talk about the range of PED. What values of PED can take place? When I look at range of PED, I make a whole spectrum where at one end I have a value of 0, and another end I have a value of infinity. So what am I looking at here is basically, I know PED is negative, so I'm going to ignore the minus sign in this discussion. And I have 0, and then I have in between I have 1, and then I have infinity. 0 is what we call perfectly inelastic, demand. And if the value of PED is 1, we call it unitary elastic. While if the value goes to infinity, we call it perfectly elastic. And we'll talk about this in a little while. Perfectly elastic demand. But if the value lies between 0 and 1, and I'm saying it's actually a negative 0 and 1 because we're ignoring the minus sign. If it's a 0 and 1 value in between, we call it relatively inelastic because it's below 1 but above 0. Or sometimes we just call it inelastic. While this value between 1 and infinity, let's say a value of 2 or 2.5 or even 1.2, anything above 1 but not equal to infinity, we call it relatively elastic. So before we talk about more about these values in detail, I just want to quickly talk about one thing which is called our responsiveness. Now, when you are here on this part of our graph, this end here, versus when you are here, the elasticity is going up because we become from a very perfectly inelastic, you're becoming more elastic, which means what we say when the elasticity go up, what we actually want to say is just that responsiveness of quantity demanded to a change in price actually goes up. So for example here there is in this case there is no response whatsoever, while here there is little response because it's relatively inelastic. There is a relatively little response, while here there is a equal response, and then here there is more than the change in price response, while here there is a drastic response. So what we're saying is just that elasticity means basically how responsive you are to a change in price. So that's one thing we need to remember, that as our value go up, our responsiveness to change in price is going up. Let's see the first value, which is perfectly inelastic demand. So let me write this: PED is equal to 0. Let's call it number 1, which is perfectly inelastic demand. If a perfectly inelastic demand, I'm saying PED is 0, which means a value, if we use our formula was PED is equal to percentage change in QD over percentage change in price, which means basically we're trying to say is just that the quantity demanded is not responsive to a change in price. So there's no change in quantity demanded to a change in price. Like if the price go up or price goes down, there is no change whatsoever in quantity demanded. What could possibly be the reason for this, and what kind of product will have such kind of a demand where even though on change in price, consumers are not at all responding to a change in price, there is no change in quantity demanded. Well, we say that the life-saving drugs could be an example of such a good where even though I'm changing price, consumers, because they need that good, they are willing to pay any price for that good. And that's why the demand curve is actually not a downward sloping demand curve for such a good. In fact, when we draw a demand curve for perfectly inelastic good, it's completely vertical. This is my demand curve. Where, look at this, guys. Even if the price is going up, right, you are not seeing quantity demand to change. So I want to make my supply curve here as well. So, for example, if this is my supply curve S naught, and currently my equilibrium is at A, what if cost of production go up, producers increases the price because supply curve shifts backward because cost of production is going up. Now, despite the cost of production going up and the price rising, consumers, because they really need this good, they are not cutting down on the quantity. So when you have a perfectly inelastic good, we say there is basically it's very important for consumer. It's as important for them that they are not willing to cut down the quantity and willing to pay a very high price for it. And we say this: there is no substitute available for such a good, because if there was any substitute available, people may switch and the quantity demanded may fall. Because there is no substitute available, the example of such goods have to be something very crucial for us, such as, for example, your life saving drug. So your life depends on that. So that's the first example where the consumer is not responsive to a change in price. The next value of PED that we want to explore is where PED is between 0 and 1. So let's write number 2. This is where PED value is between 0 and 1. And this is what we call a relatively inelastic good. So if you have a relatively inelastic good, the first thing when we look at formula for us, PED is equal to percentage change in QD over percentage change in price. The only reason why the value will be below 1, because the value has to be below 1, where your numerator is less than your denominator. If your numerator, which is percentage change in quantity demanded, is less than your denominator, which is percentage change in price, we will have a value of PED less than 1, which would mean I'm looking at quantity demanded to be not so responsive to a change in price. And the reason why this could be that people are not too responsive to a change in price is because they might have what we call sometimes strong liking for the good, like a brand loyalty for the good. If you have a strong brand loyalty for the good and the price of that good goes up, you may not switch really easily. And the reason is basically you might not want to try the other substitutes, or you may feel the other substitutes are not good enough. A good example is just that if the price of tea goes up, I mean, for me, it will be difficult to switch to coffee, though I do drink coffee sometimes, but I'm more of a tea drinker, and therefore for me the demand for tea is kind of like inelastic, not so responsive to a change in price. So when we make such a curve where the demand is inelastic, we try to make a curve which is very steep. So I'm making linear curves. A linear curve which is very steep would be what we call inelastic in demand. Where, look at this, guys, even if the price goes up by a lot, so let's say this is P naught and Q naught, and if the price goes up by a lot, let's say by 20%, the quantity is changing lower than the change in price, only by less than 10%. So in this case, my PED would be a minus 10% over 20% or 0.5 negative. Now this 0.5 negative of course means there's an inverse relationship, but 0.5 means less than 1, which means inelastic, not so responsive. So this is the case for a good where there's a strong brand loyalty or less close substitutes available. Next up is our unitary elastic demand curve. So this is number 3. Our number 3 is what we call our unitary elastic demand curve. This is a curve which is, I mean, if you ask me an example for it, I may say I do not know, but any good that has a value of PED equals to 1, we call it a unitary elastic demand curve. How do you get a PED of 1? Well, this means that my PED of 1 would mean PED is simply percentage change in QD over percentage change in price. So if I am getting a value of 1, this means the denominator and numerator have to have the same value. In other words, percentage change in QD must equal percentage change in price. Now that would make my value to be equal to 1, or in that case minus 1, but we're ignoring the minus sign. So what kind of a good has the value of PED equals to 1? Well, I do not know, because any good can have that response, but if let's say a good always has a PED of equal to 1, then we say the curve for such a good will not be linear, because if you are always going to have a equal and opposite change to a change in price, then your PED, your demand curve may look like this, where this is called, there's a name for this curve, it's called rectangular hyperbola. And there is a particular sort of feature of this curve is this: if the price goes down, let's say by any percentage, let's say 10%, we will always see the quantity demanded to go up by an equal and opposite demand, let's say 10%. So minus 10% will lead to plus 10%. In other words, this rectangle that is being formed here, and that's why it's called rectangular hyperbola, this rectangle that is formed here will have an equal area to this rectangle. In other words, what I'm trying to say is this, that the P0 times Q0 must equal the P1 times Q1. This rectangle that is formed has an equal area. But more importantly, whenever the price goes down by 10%, quantity demanded will go up by 10%. If the price goes up by let's say 2%, quantity demanded will go down by an equal and opposite. So there is an equal and opposite change in change in quantity to a change in price. Next up is what we call, number 4 is what we call relatively elastic good. So we're moving along the spectrum, and relatively elastic good would mean I have a PED which has a value which is between 1 and infinity. Now this is again, if you use the formula of our PED, where I say the numerator is percentage change in QD over percentage change in price, the only way I can get a value more than 1 is where the percentage change in QD is greater than percentage change in price. So in this case, what we're saying is this, that the good has a more than proportionate change. Let me write this down: more than proportionate change in QD to a change in price. The good is very responsive to a change in price. So, for example, if the price goes up by 20%, price goes up by, for example, let's say 20%, the quantity demanded may go up by more than 20%, let's say 40%, you will have a PED of 2. So how do I show that in terms of a diagram? And what does it mean to have a relatively elastic good? Well, a relatively elastic good will have a demand curve that will be very, very flat or relatively flat. So if the price of a good goes down, you can see this, the price is going down by, let's say, a little percentage, the quantity demanded will go up by much more. So, for example, let's say the price goes down by 10%, quantity demanded may go up by, let's say, 40%, and my demand curve might look like to be this, where my PED will be, for example, in this case, 40% over 10%, or 4. So, in this case, what we say is that there is a more than proportional change in quantity demanded to a change in price, and the reason is basically that there are many substitutes available. So more substitutes are available. So there is a possibility of people to switch very easily. More substitutes available. There is a weaker sort of brand loyalty, and as a result of that, people don't find it difficult to switch when the price of a good is going up, making the good to be more responsive to a change in price. The last case we want to discuss is what we call perfectly elastic good. So perfectly elastic good is a good where PED perfectly elastic. So perfectly elastic good is a good where the PED is equal to infinity. Now this is a good where we say this, that your demand curve is completely horizontal, completely flat, and such is a good that if the demand curve is like this, let me show you an example. If the demand curve is like this, right, and let's say supply goes up, for example, supply is like S0, supply goes up, you can see this, that despite an increase in supply, the price isn't changing. The price stays at P0. So what kind of a good would be such where the price isn't changing? Well, we say this is a good where the price will be P0, and if the producer decides to increase price above P0, no one will buy from him. But if the producer decides to reduce price P0, then basically there will be a loss of revenue. This is a good where what we say is that you cannot charge any price but P0, and you are kind of like in a market where there are so many firms that they are actually perfect substitutes available for your good. If there are perfect substitutes available for your good, then what happens is that let's say there is a perfect substitute available for a good I'm selling, and let's say I'm selling it for $10, and my competition, which is also selling the similar identical good, raises the price to $12. Will anyone buy from him knowing that there is another producer with a price of $10? And the answer is no. So that producer who raises his price above, let's say, P0, will lose all his sales. So this demand curve suggests that a producer can sell any quantity at the going price P0. So this is like a P0 will be what we call market price, and if the market price is P0, and if I charge any price other than P0, I may not be able to sort of sell much, but if I am charging any price P naught, then any amount can be sold. So if I have like 20 units, 200 units, 250 units, any amount can be sold at the market price. So, what kind of goods will have such kind of elasticity? Well, we say that in the market for vegetables, where we are sitting in, for example, a mandi where there is a lot of sellers, and you are also one of the sellers, then you will have a perfectly elastic demand curve, because you can't charge any price below, you can't charge any price above P naught, and any price below P naught doesn't make sense to you as well, because you will make lower revenue. So, the idea goes this, that when the demand is perfectly elastic, producers will only charge the price that is going in the market, because they are afraid that they won't be able to sell anything above that price P naught. And such is the case for goods where there are perfect substitutes available. So basically, consumers have tons of choices to switch. There is no brand loyalty whatsoever. And why will that be? Because there is a perfect substitute available, so there is no brand loyalty, and so switching is extremely easy. In the case of a linear downward sloping demand curve, we actually say this, that when you look at elasticity of demand for a linear demand curve, so let's make a linear demand curve like this one. If I have a linear downward sloping demand curve, then what we say is that PD falls as quantity rises. So if you look at this point, let's call this point, let's say P naught versus P1, and let's call in the middle, let's call it P2, Q2, Q1. So if you look at P naught, at this point, my PD of this demand curve will be infinity. But at this point, the very end, my PD will be 0. So PD is actually falling from infinity to 0 throughout the length of the demand curve. And right in the middle, my PD will be equal to 1. So the first half of the graph, between 0 and 1, between P0 and P2, your PED, the value of PED, will be between infinity and 1. While in the lower half, the PED value will be between, let me write this properly, in fact, it will be from 1 to infinity, and in the lower half, the value will be between 0 and 1. So what we say is that when we make a demand curve that is downward sloping, we have a PED that falls throughout the length of the demand curve. In fact, it starts from infinity on the y-axis and become elastic in the upper half, and becomes unity or unitary in the middle, while it falls to become perfectly inelastic in the quantity axis. And there are explanations for this. Is simply that like when the price is very high for a good, consumers will be more responsive to a change in price, and that's why a very high price, the responsiveness is high, but at a very low price, responsiveness is nothing or very low. So the lower the price, the lower the responsiveness. And there's also a formula we sometimes use in this case, which is very useful for calculation, where PED is equal to 1 over slope times P over Q. This formula is useful because it can actually help us suggest why these values are what they are. For example, at this point, if I look at this value, my price is 0, because price is 0 and I have a particular quantity. So no matter what the slope is, my PED will be 0. While at this point, my quantity is 0, so my denominator is 0. So, and we know this, that anytime denominator is 0, the value will become infinity. So if I use this formula, PED is equal to 1 over slope time P over Q, I can find the values, and I'll find the corner values to be infinity and 0.
The next discussion we want to have is about factors affecting PED. So what are the factors that determine the elasticity of demand? The first one is basically called the number and closeness of substitutes. Well, the higher the number of substitutes, or the more closer substitutes are regarded or related to each other, we say the higher the PED will be. And the reason is very simple. If there are more substitutes available, it's easier for a consumer to switch to consumption of another good if the price of a good goes up. So more substitutes means more options available for a consumer, and therefore more options available means higher will be the PED. Similarly, if two goods are very similar to each other, we call them close substitutes. And so therefore, closer the substitutes, we say higher will be the PED, because the consumer will be very responsive to a change in price. If the price of one good goes up, he will switch to the other one, which he deems as very, very close substitute. So let me write this. Higher the number and closeness of substitutes, higher will be the PED. So that's the first thing that we want to talk about. Here I also want to talk about an important aspect, which is basically called narrower definition. What do I mean by narrower definition? Well, if we think of Coke versus Pepsi, Coke versus Pepsi are part of soft drinks, right? In the soft drink market, you may have Sprite, you may have Fanta, you may have Coke and Pepsi. So that's a broad definition. So soft drink is what we call a broad definition of a cold drink, right? And within this soft drink, there is a narrower definition of cola, where if you can say that the narrower the definition, the lower will be the elasticity demand. What do we mean by this? Well, look at this. In the cola market, you only have two major competitors, which is Coke versus Pepsi, right? But if you look at the soft drink market and you look at Coke would have competition with Fanta, with Sprite, and with many other players. So the more narrow our definition, the lower will be the competition, and therefore the more inelastic will be your demand. So narrower the definition, the more inelastic the demand. The next point I want to discuss is about the proportion of income spent. So number 2 is proportion of income spent. And here what we say is that if a good has if a good is expensive, if there's a large proportion of income is spent on the good, let's say a luxury good, then small change in price, let me write this, small change in price will lead to a large change in quantity demanded. So if there's a small change in price, there will be a large change in quantity demanded. And the reason is very simple, that it takes up a large percentage of our income. We will be very responsive to it, to a small change in price. If, for example, on the other hand, the good takes up a very small proportion of our income, like for example, salt takes a very small proportion of our income, or Matchbox may take a very small proportion of our income, then even if the price goes up significantly, the demand will remain inelastic. It will not be too responsive to a change in price. So larger the percentage of income spent on a good, larger will be our response. Therefore, you would see this, that there will be more elastic demand. Good example would be luxury goods in this case. The third one is what we call, number 3 is what we call time period involved. Well, if I give a consumer only one day to leave the consumption of a good, which he has been doing for many days, he will have what we call very difficult time to do so. So what we say is this, that longer the time period under consideration, the more elastic will be the demand. Elastic will be the demand. Why will the demand be more elastic? Well, if there's a longer time period under consideration, it's easier for consumers to sort of find a substitute. So the first reason is that it's easier to find a substitute. It's difficult to find a substitute in a small time period, but it's easier to find a substitute in a short time period. Similarly, it's easier to not only find a substitute, but it's easier to switch the consumption to a new good. So you can change your consumption pattern because you are able to be given a lot longer. But if there's a very small time period involved, let's say you ask a consumer to switch in a week's time, it would be difficult. Like, for example, I eat a particular kind of cereal, and if the price of the good goes up, I might find it difficult to switch in a week's time. But yes, if the price keeps on going up in a month's time, or in some week's time, I can switch to another cheaper substitute. The fourth factor is nature of the good. If a good is what we call habit forming, such as cigarettes, such as, for me, for example, tea, for some people, for example, coffee, then the nature of the good is such that it is habit forming, and basically, when such is the nature, then it is a good which has an inelastic demand. So even if the price goes up, it becomes difficult for consumers to switch because they have a habit of consuming that good. So it becomes difficult for people to switch or stop the consumption of that good. So the nature of the good could be a factor that can make the demand to be inelastic. The last factor that we want to discuss is basically whether the good is a necessity versus a luxury. If a good is a necessity, then this means that it is important for our survival. Important for survival. And if it is important for survival, then automatically we will say this, that the demand will be inelastic. Why? Because people will not find it easy to switch or stop consuming those goods because they are important for our survival. So water, food, housing, clothing, all of these are necessity goods which have an inelastic demand because consumers find it difficult to switch.